So we're switching over to marine, and I've drawn this kind of cross section of the ocean here. And something that you probably know about the ocean is that it's not fresh water, right? It's salt water. We call it salt water. It's got a whole bunch of other stuff in it. If you try to drink it, which you can in small amounts, it's not a great experience. Or even getting hit in the face with a wave can be a pretty traumatic experience. But when we think about ocean basins, they all don't contain the same amount of salt. So generally, in warm areas, ocean or basins that contain seawater that tend to have at least what we call restricted flow tend to be more saline. So at the large scale, something like the Mediterranean Sea, which is again connected to the Atlantic, the water there has a higher salinity than it does out in the open ocean because, again, at the Strait of Gibraltar is kind of this pinch point. So that's kind of map scale. In like localized scales, and this could vary in kind of scale from a couple of kilometers here or to maybe 1 kilometer. Oftentimes, in certain environments, we may get a reef situation. So there's critters out here building their reef. And when they do, they tend to create these mounds. This is a reef mound. And what a reef mound does, well, it does a whole bunch of things. But in our context, it actually limits the flow of water back and forth into what we call the back reef lagoon. So here we can see our back reef lagoon. And again, I'm going to bring out the sun. Here we go. We got the sun there. And it's heating water, right? It's one of the things that it does, particularly in places closer to the equator. And what we see is actually this shallower water tends to warm faster than the water out here that's fairly well mixed. And that causes increased evaporation from these back reef lagoons. And that, in turn, draws more water in from the open ocean. So this is great. And what we start to see in these lagoons is we can actually get precipitation of minerals, fairly common minerals in seawater in kind of the reverse order of their solubility. So as concentrations increase, the first thing that we start to see is calcium carbonate that gets deposited, generally as a rock known as limestone. As we continue up the kind of solubility of some common things dissolved here, we would actually get gypsum. So we're kind of going in order of deposit here. Then we get halite. Halite is a mineral that you know of as table salt, right? Halite is sodium chloride. So when we get to the last kind of phase of evaporate mineral formation, we get into potassium and magnesium salts. We're not really going to talk about those. The chemistry gets a little heady, and that's not really for us. Really what I want to focus on here is actually halite. So halite is salt. And so this is the notion of getting salt from the ocean, which obviously seems fairly easy to do. But in these types of conditions, we can also get salt in rock form, what we would call rock salt. You may have seen like a Himalayan salt lamp. You can buy those at the kind of magic witchcraft supply store or something, or Walmart or anything. And that's salt that's formed essentially in exactly this condition. It's been exposed to the surface and actually recovered and mined. It happens often, and there's a thick section of these rocks exposed kind of in the foreland fold and thrust fold of the Himalayas. So oftentimes they're sold this kind of Himalayan rock salt lamp. But again, it actually happens quite a few places. So in the modern world, there's two kind of really big changes that have happened to salt. First of all, since the Industrial Revolution, we can make salt fairly easily. We have the energy to do that. And also, we don't really use salt the same way as we used to. So in antiquity, there's a couple of different ways that we would generally get salt. The most common is, again, using the sun and using these shallow ponds that we call salt pans. And again, you could put a pump here, a wind-powered pump, or you could have people do this with buckets to essentially fill these little tiny salt pans with water, and then that water heats up and evaporates and leaves behind these salt crystals. So that's fairly labor intensive. So really until about 150 years ago, salt was one of the primary things we used to preserve food, and largely fish. So we used it a lot, but it was fairly hard to get. And you can actually see, this is still in many places how we recover salt, although we do it at a much different scale. You can see here, this is again kind of near and dear to my heart because I've spent a lot of time here. You can see these are the salt evaporation ponds in Sardinia, near the town of Cagliari, it's the capital of Sardinia. And these have been in production for 1,500 years, right? So the year 500, I think, was when these kind of first started being active. But obviously they've included modern technology. So another way that salt was recovered really kind of in antiquity, which I always feel like it kind of helps us understand how things work in a modern world, is we could have situations where water is coming up through the earth, groundwater, it might be hydrothermal water, it might be slightly warm. If it's passing through rocks that have halite in them, generally probably not a full layer or generally not like beds of salt, because oftentimes they lead to sinkholes and things. But either way, if water is passing through, there can be a situation where we get what we call a brine spring or a salt lick. And these again have existed and we've known about them for a fairly long time. If you have salty water coming to the surface, well, that's both good and bad, right? So first of all, that you can't drink it. That's a bummer. But you can actually modify the surface of the earth, so you've created a kind of a stepping pattern of natural salt pans. And in this case, you don't have to have someone carrying the salt in or a pump pumping it in from the open ocean like we saw in the kind of coastal salt pans. In this case, the water is being sourced and the salt is being sourced naturally. Probably the most famous are the salt pans of Maras in Peru. And this is exactly the situation, it's kind of what I drew in the diagram, where there is a brine spring that comes out on this hillside, and over the years, people have actually established all of these small salt pans, and there's enough evaporation, the evaporation rates are high enough that it produces salt, and it becomes a commodity, right? Again, a natural resource. So one of the things that I really like I kind of want to finish on when we're talking about, marine evaporates and really just focusing on salt in that case, is it has an incredibly rich history. The human history kind of interacting with salt is totally mind-boggling. There's a great book just called Salt, which kind of goes through the entire history. But the big picture that I like to point out is that salt used to be fairly hard to get before we realized you could really mine it. There's lots of ways to process it industrially. We primarily used to use it as a food preservative, and it was a spice, right? It had high value, a soldier worth his salt, people would get paid in salt and things like that. But currently, the majority of our salt, a small amount of it is actually used in food, but most of it is used for melting ice on highways, right? That's kind of the ultimate kind of sad end to the fate of salt in human history. It used to be this highly revered material, and now its primary use is actually melting ice on the freeway. Okay, so that's going to finish it up for evaporate resources. Hopefully you learned something. All right, I'll catch you in the next video.